I'm doing this one in completely different page. So derivative is saying that suppose I'm defining one function. Suppose f is a real valued function. Real valued function means that means that the real numbers actually, okay. But if you can't say it's a real number because it's a function, right? So real valued function of x, function of y, like this, okay. And a is a point. The two things is given, one in its domain. So what is domain, what is function, this is we will all discuss in chapter 2, okay, not now. Just you remember that if is a real valued function and if is any point. So like in your class 11 syllabus, all f is real valued function, so no need to worry about that, okay. If f is a real valued function and a is a point and its domain, then it's saying that derivative then derivative of f at a derivative of f at a is defined by limit h tends to 0 f of a plus h minus f of a divided by h. This is our derivative formula, definition actually, basically. So derivative, this is a basic concept of derivative. The derivative of f at a point a is defined by limit h tends to 0. Okay, limit h tends to 0 f of a plus h minus f a divided by h. Now, and one more thing here, we have to remember that provided, because class 11 all function will exist, okay, all limit will exist for your class. So like here I'm saying that provided limit exists. Provided limit exists. If limit is not exist, then this will be no value. Okay, and the derivative of fx at a is denoted by f dash, okay, or later we will know this is a derivative sign d by dx of fx at a. Okay, so this is basically this, for this thing we will learn later, no need to discuss this one now. But derivative will always still always will write like this. Suppose you have to find the derivative of fx at a, so derivative of fx will be f dash a, okay, and formula is this, okay, formula is this one. Let's try to do one question, then we will example. Let's do one example. Let's see, anyone want to join? Let's suppose I'm doing one example. Suppose find the derivative. Fx is given 4x plus 5. We have to find derivative at x equal to 3. Okay, we have to find the derivative of x equal to 3. So basically what we have to find? We have to find f dash a here is 3. Okay, our formula is limit h tends to 0. Where is h? Let me show you again. H tends to 0, the formula f of a plus h minus f of a plus h. What is a here? Here a is 3 plus h minus f of a. That is 3 here and divided by h. Okay, so what you have to do? We have to find the f of 3 plus h. So limit h tends to 0, h. Okay, so f of 3 plus h will be what? Fx equal to 4x plus 5. So what will be f of 3 plus h? So instead of x, we have to replace 3 plus h. Okay, so it will be 4x. So instead of x, I will write 3 plus h plus 5. So this is f of 3 plus h, right? Then we have to write f of 3. So I am showing you f of 3 with a different color. F of 3 will be 4 into 3 plus 5. Why I am using bracket? Because you will miss this sign. This is minus, so it will be minus sign. If you don't use bracket, you will still will write plus sign. So better to write in brackets. Okay. So I hope this part is understood. You f of 3 plus h is 4x instead of x. We are now just replacing 3 plus h. The next line, it will be limit h tends to 0 h. If you subtract this, I mean simplify this one, it will be 12 plus 4h plus 5. Here it will be minus 12 minus 5. So let cancel whatever will be cancel. 5 cancel, 12 12 cancel. Only remain will be 4h. So here it will be limit h tends to 0, 4h by h. Okay, so answer will be 4. Because look, there is no h is here, so you can't put h, so answer will be 4. The derivative of fx at x equal to 3 will be 4. Okay, so this is very simple things. Okay. Next, this is a very important part of this today's class is first principle of derivative. First principle of derivative. Wait. This is very important. This is I'm writing here. First principle of derivative. First principle of the derivative. What this derivative is saying suppose okay this one now I'm writing okay suppose f is a real valued function comma the function defined by function defined by limit h tends to 0, h limit will be f of, just wait a minute, okay, x plus h minus f of x, where the limit exists. Okay, in the meantime, I'm writing this one. In the meantime, do one question. Okay, I'm giving you one question. Using the previous concept, do this question. If x equal to 3x square plus 1 and find derivative at x equal to 2. If the question is clear, using the previous this concept, okay, find the derivative of 3x square plus 1 at x equal to 2. Okay, find out. And I'm writing this one. If you want, you can write the question. Okay, because this question writing will take a little time. Is defined by is it done? The question is 3x square plus 1. 3x square plus 1. This question is done. Anyone did? Oh my goodness, Tuna, they are joining so late. No, not correct. Three? No, not correct. I don't know how you got three. Later, it's okay. Later, I'll show you. Okay, this question I'm giving you homework for now. For now, I'm giving you some homework. You can try this one later. Otherwise, I will show you later. Okay. Homework. Okay. Let's explain the our first principle. This is very important. This formula is important for the JEE also. Okay. So this is the first principle of the derivative. First principle of the derivative is saying that suppose f is a real valued function. Suppose f is a real valued function. Okay. And the function is defined by this limit h tends to 0 f of x plus h minus fx by h. Okay, you can see the same thing, but here instead of a I use x. X is for generalize. Okay, a we took the a is any point, but x is for any x is for generalization. Okay, where the limit exists is defined to be derivative of f at x. Okay, and denoted by f dash x, or as I told you, sometimes it is denoted by ddx of fx also. And this formula is very important, very important formula. This formula. So derivative of f at x is denoted by this. This formula is extremely important formula. This is called as first principle of derivative. This is first principle of derivative. Okay. So let's do some question, then you will understand. Okay, you will understand when you do some question. So suppose I'm starting from very important question. So you can see the first principle and the previous definition of the derivative is same, but in first principle you can see that we took x. Okay, so that it is generalized for any function. We can use this formula. So suppose I'm taking this example. Let's do some example, then you will understand more clearly. Okay, suppose fx is given x to the power n, where it is saying x is, sorry, where n is positive integer, where n belongs to positive integer. I hope all of you know this sign. It is sign of positive integer. Okay, how to do? What will be f dash x? Just put in the formula limit h tends to 0, right? F of x plus h, f of x plus h minus f of x divided by h. Okay, so then limit h tends to 0. What will be f of x plus h? If f of x equal to x to the power n, what will be f of x plus h? It will be x plus h to the power n. Okay, and fx value, whatever fx value is there, you just put the fx value and then h. Okay, now anyone have doubt till this step? Let me know. If anyone have any doubts till this step 2, let me know. I'm writing here some binomial theorem. Okay, if anyone have any doubts till this step, please let me know. Okay, I'll see your comment after this doing this. If anyone have doubt till the second step, please let me know. Yes, sir. Could you please explain again? Okay, explain again. Explain again means which is this example two or the principle? Which one you need more again explanation? Does what it called? The second this one, the problems or the theorem? Sorry, principle. Which one? Example. Okay. So in the example, okay, I'm starting with the this derivative. So basically, derivative formula is that f of f dash x equal to limit h tends to 0 f x plus h minus fx by h. Okay. So here also look, our fx was given this. Our fx is given x to the power n. Okay, and it is saying that n belongs to positive integer. Okay. So if it is saying we have to find the f dash x, that means the derivative of fx. Okay. So what we just use the formula. Look, I just use this formula directly. Okay. Now you may have doubt on this part. Okay. How this came? Suppose I'm giving you graph. Fx is equal to x to the power n. So what will be f of x plus h? X plus h will be what? X plus h to the power n. Understood? Look, fx is equal to, I am writing x to the power n. Okay, there is no change. But what is will be fx to the fx plus h? If it is xp, suppose I have to find fp. What will be fp? It will be p to the power n. The function, just a general function. So instead of, we have to replace x with x plus h. Am I clear now? Am I clear now? This is just, we have to put the value of the function. Is it clear now? Till the step, this step, till this step. This step, is it clear? Other, look, I did not change anything. I just change here fx x plus h to the power n, and fx, look, we just directly put the x to fx value. Fx was given x to the power n, and other I did not change anything. Okay. Now let me know. Is it clear now? Okay, fine. So now, last day, if you attend the last class, I hope you remember, we was discussing about the binomial theorem. Okay, I told that binomial theorem this year omitted from the from your syllabus. I don't know why, because of this pandemic, maybe because. So this is the binomial theorem. We have to expand. We have to expand this x plus h, and this is the formula. Okay, so basically you have to remember this formula for sometimes. Binomial theorem formula you have to remember for some time. I will later I will show you the tricks how to remember. Okay, but for now I have to f dash x equal to limit h tends to 0. Instead of x plus h to the power n, I will write this one. Okay, so I have to write x to the power n plus n h x n minus 1 plus n into n minus 1 by 2 x n minus 2 into h square dot 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 continuation h to the power n minus x to the power n. Where this x to the power n came? This x to the power n. Okay, this x to the power n, don't forget. Okay, the expansion of x plus h is this, and this x to the power n is here, and denominator it will be h. So from this you can see one thing, that this x to the power n, this x to the power n, this x to the power n and this x to the power n will cancel. Okay, so what will remain? What will remain? Remaining part will be, and this is actually a very important formula. Remain will be limit h tends to 0. Okay, one more thing. Remaining part. Look, everywhere h is there. Here is h is there. Here also. Oh, sorry. Here, this is not minus plus sign. This is second term is nh x to the power n minus 1. Okay, there is no plus between them. So look, every term x to the power n and x to the power n cancel. Look, after that every term have as h till h to the power n. So I will take h common. So what will remain? N x to the power n minus 1. Okay, then here it will be n minus 1 by 2. It will be x to the power n minus 2 into h, because here it was h square, plus continuation h to the power n minus 1. Okay, h to the power n minus 1. H to the power n minus 1. Why n minus 1? Because h to the power n was there. So if I take h common, 1 will reduce, divided by h. Why I am taking h common? So that I can cancel h and h. Okay. Now, if you see the denominator, look, every term has h except the first term. Is it clear? First term don't have any h. Inside this one, first term don't have h. So, okay, I'm writing again. Limit h tends to 0. What is remaining now? N x to the power n minus 1 plus n into n minus 1 by 2 x to the power n minus 2 into h plus continuation, it will be h to the power n minus 1. Continuation means here also, look, h now h power is increasing, so here h next will be h square h cube until h to the power n minus 1. So if you put h equal to 0, look, all the terms will be 0 except the first term. So this answer will be n x to the power n minus 1 plus 0 dot 0. Okay, so answer will be n x to the power n minus 1. Is it clear? This question is important question also. This question is very important question also. Any doubt regarding this question? Any doubt regarding this question? Next, I'll proceed to the formula. Let me know if you have any doubt. So our formula, let me write the formula. Fx is equal to x to the power n. Therefore, any doubt regarding previous question? Besides the binomial expansion, binomial expansion for now I can't explain, because this is a completely different chapter. Okay, just remember this formula. You have to remember, because sir, we put the value h equal to as 0. Yeah, we are putting, because look, this is as before also, if you remember, before also we used to put the value 0, right? After simplification, because look, first line also, if you want to put 0 in first line, you can put, but look, in first line if you put denominator is 0, so our in this limit derivative chapter, our what it called, our motto will be same, that we have to remove 0 from the denominator. Okay, we can't make the denominator as 0. So when we so that I take h common, right? Understood? So that h cancels, the denominator will be now 0 free. Now after that we have to put the 0 because we don't have it. Even if the first term, suppose the first term have h, okay, you can put 0, no problem. But we have to check that whether the denominator is 0 or not. We can't make denominator as 0. Okay, after this line I just put h equal to 0 here. Look, here I don't know h, so I'm not putting anything. So here if we put h, I'm directly writing here. Why? Because again I have to write. Okay, if you want I can write again. Instead of this h, I'm putting 0. So 0 into this thing will be 0. Similarly here also, this continuation, here also many zeros are there. Okay, and here also 0 to the power n minus 0. So all value will be 0 except the first term. Okay, and this is actually our very important formula. Look, if you see our function, what was our function? Our function was fx equal to x to the power n, right? And what is the derivative we got? We got derivative if is n to the power n into, derivative we got n into x to the power n minus 1. So our formula is, if suppose fx is equal to x to the power n, the derivative of x will be, derivative of x will be n into x to the power n minus 1. What is, how to remember? Whatever the power will come as coefficient and the power will decrease. So suppose fx is equal to 3x square. What will be derivative of f dash x? Let me know. What will be derivative of x dash x? Using this formula, the yellow highlighted color formula, let me know, if fx is equal to 3x square, then what will be the f dash x? Fast reply. Very easy things. Using the formula, let me know. You don't have to do derivation, okay? You just use the previous formula. What I told? I told, suppose fx is equal to x to the power n. Okay, so the n will come in front, okay, and the power will be reduced by 1. Look, n come in front, okay, the power come in front, I mean as a coefficient, and the power reduced by 1. So what will be the derivative of 3x square? Fast reply. Derivative of 3x square. See, yeah, what is 2 minus 1? Just calculate. What is 2 minus 1? X to the power 2 minus 1. What is that? Okay, what about the others? No response? No, 6. Look, Nadia. Uh, you see, look, 3, here 3 no change. Okay, now this 2 will come in front, right? And power of x will reduce by 1. So 3 into 2 is how much? 6. And this x will be x to the power 2 minus 1 means what? X to the power 1 actually. So we don't write x like this. Okay, 6x. Yeah, 6x is the answer. Similarly, I'm giving another question. This is suppose one question. Another question is, suppose fx is equal to 5x to the power 5, 4x to the power 4, 3x squared plus, not 3x squared, 3x cubed. 3x cubed. Okay, what will be the answer? Oh, it's okay. You don't need to do this one because for this one you need algebra. Wait. I will do later. Okay, this is enough for now. For now, you did this one. This is enough. So let's do another question using first principle. In your book also few question is there. Um, yeah, logarithm. Let's do this logarithm. It was example 2. Yeah, example 3. Let's do example 3. Logarithm 1. Example 3 is in doubt. Let's see. Okay, fine. Yeah, example 3, when fx equal to log x. Fx is equal to log x. Okay, we have to find the derivative using the first principle. So what would be the derivative f dash x? Okay, so it will be limit h tends to 0, h f of x plus h minus f of x. Okay, so limit h tends to 0, f of x plus h will be what? Log x plus h minus log x divided by h. So if you remember the log properties, when it is minus, it will be divided, right? Limit, sorry, limit h tends to 0. I'm writing like this. Oh, log 1 you deleted now. Wait a minute, okay? It's okay. It will be log of x plus h by x. Sorry, x plus h by x divided by h. Okay, this is log property, that log a, we know that log a minus log b will be equal to log of a by b. Okay, when division is minus. Okay, next it will be limit h tends to 0, log of 1 plus h by x. Okay, look here, I'm just splitting x by x, it will be 1, and h by x is this. And here I'm writing h by x into x. I can write this. Okay, so it will be into log function. Yeah, so next line I'm writing limit h by x tends to 0, and here h by x log of 1 plus h by x into 1 by x. Okay, so look, this part did not change. Look, this part did not change. Only change is what? Here was x is multiplied, so I am taking the x to outside, so it is 1 by x. Okay, and look here, 1 by x, here x is a constant because it was x, h tends to 0. Now one more thing, here h tends to 0. H tends to 0, right? So what will be h by x tends to? It will be 0 by x. So 0 by x will be what? 0. So I'm writing here h by x also tends to 0. Why? Because look, we are having we can see some h by x in the terms. Now, according to this one, this is one. One formula is there. I'm showing you the formula that limit x tends to 0, okay, log 1 plus x by x equal to 1. This formula we skip because this year again this is also omitted. This year this thing also omitted. I don't know why. This is important, very important part actually. So I did not show you this one, but remember this formula. This is important one for especially for competitive exam, that limit x tends to 0 log of 1 plus x by x equal to 1. Okay, and another one is there, that is exponential. I will show you when I will do exponential. I will show you. So you can see limit h by x tends to 0. Here consider h by x equal to x. Okay, and look, log 1 plus h by x and denominator also divided by h by x. Okay, so this full value this full value we got equal to 1 as per the formula. Okay, so ultimately what will be the answer? Answer will be 1 by x. Okay, so what we got here, here also we got one formula. Suppose whatever I am writing in the black pen, this is all formula. Fx is equal to log x. If fx is equal to log x, f dash x will be 1 by x. This is also very important formula. Okay, so I'm all deriving the formulas actually now, till now. Am I clear? Last time we got, if you remember, that x to the power n equal to x to the power n, and then derivative of x fx will be n x to the power n minus 1, and here log x we will get 1 by x. Is there any doubt regarding this log x portion? You can just find only this portion. You may have a little confusion. This is the for confusion you can clear with this formula. Okay. Let's do some other question also. Let's do some yeah, derivative. This will be good. Sin x and if in doubt, let me know. Otherwise, I'm going to the next question. No. Here we don't need to put. Okay. Here it is a structure of formula. Okay. Here we will not put the for h by x equal to 0 because it is giving you this formula. Okay. If you remember last time we did like for sine, like limit x tends to 0 sin x by x. We know this formula value is 1. Look, when we always try to construct this formula, okay, limit x tends to 0 sin x by x, okay, we don't put the value here. We always try to construct the, so that we know, because we know this value is 1. Here also same, limit x tends to 0 log 1 plus x by x equal to 1. So we construct this one, we construct this like this, okay, so that we can put that is equal to 1. Am I clear? So whenever you are getting limit value, limit this kind of construction, then we will not put the value. Okay, suppose limit a sin x by x or limit x tends to 0 1 minus cos x by x. So always we will put the value there, okay, not the formula. Sorry, we will put the formula there, not the value. So this is just something we have to keep practicing. Okay, it is only practice can help you. Otherwise, if you think that what happened? If you think that I will just study before the, that will not help. Okay. Okay. Let's next thing is fx is equal to sin x. fx is equal to sin x. So here we need the trigonometric formula. Okay, a plus b, sin a plus b we need. Let's find out. So f dash x, what will be f dash x? It will be limit h tends to 0, h f of x plus h minus fx. So just put the f of x plus h limit h tends to 0, h. What will be f of x plus h? It will be sin x plus h minus fx is sin x. Now put the value of x plus h. Value means the formula. Sin a plus b formula. Let's see how many of you remember this formula. Sin a plus b. What is the formula? Sin a cos b plus sin b cos a, right? This was our formula. So we will use sin a plus b formula in the here. So h tends to 0. Here it will be h. Sin x plus a. So sin a plus b, sin a cos b. So it will be sin x cos h plus sin h cos x minus sin x. Okay. Oh, sorry. We will not use this formula. We'll use the different formula. Wait. We'll use a different formula. This formula will not help you. We'll use this formula. Anyone remember this formula? Sin A minus sin B. We'll consider this is sin A. We'll consider this is sin A and this is sin B. Anyone remember this formula? Sin A minus sin B? I don't think so. So I'm writing the formula is 2 cos A plus B by 2 into sin A minus B by 2. Okay, this was the formula. Understood? So here it will be 2 cos A. What is A? X plus H by 2. Sorry, X plus H plus X. Okay, A plus B, right? So A is this and B is X. So A plus B by 2 into sin A minus B. What is A minus B by 2? Okay. This formula, if you don't remember, just check from the chapter 3, trigonometry theory. And this is the very important formula. All formulas of trigonometry is very important. So now you can see here x cancel. Sorry. Here x and x cancel. So what will be remain? Limit h tends to 0. Here I can write 2 cos 2x plus h by 2, and here I am writing sin h by 2, here h by 2 into 2. Let me explain this one. I hope you the numerator part you understood. Sin x cancel, so h by 2 will remain. So look, sin h by 2 here. Now denominator already h is there, right? So I'm writing h divided by 2. Why? I'm just keeping this value same, because we have one formula that is sin x by x, limit x tends to 0, sin x by x equal to 0. Sorry, equal to 1. Okay, so I'm trying to make the denominator same as the sine angle. So I'm writing h by 2, but we can't write h by 2, so I'm multiplying 2. Look, this 2 and this 2 will cancel and it will remain same h. Now here these two and these two will cancel. Okay, so next line it will be, next line I will use the algebra of the limit. So it will be limit h tends to 0 cos 2x plus h by 2 into limit, I'll write the tends to later. Here I'm writing sine h by 2, and here I'm writing h by 2 tends to 0. Why I'm writing like this? Because we have formula. We have this formula that limit x tends to 0 sine x by x equal to 1. So we will try to construct in the formula structure so that we can directly write the value. Okay, we can directly write the value. So look, this formula, this will give you 1, right? And look, h tends to 0, so h by 2 also will be tends to 0. Okay, I hope there is no confusion in this. And this thing we have to practice and practice more. Okay, otherwise you can't do this one. So on the first part here I will directly put 0 because look, there is no h in the denominator, so it will be cos 2x plus 0 by 2, and this value will be 1. So it will be cos 2x by 2, 2x by 2. So 2 to cancel, it will be cos x. So what we got actually? We got derivative of sine x is cos x. That is the formula. Okay. Do one thing. Whatever the formula I'm writing now, I'm telling the formula. I'll mark this one as the formula. Suppose fx is equal to sine x. So f dash of x will be cos x. This is very, very important formula. Very, very important formula. Okay. Now I want to give you some homework. Okay, let me know first, is there any doubt on this first question? This sin x, if you have any doubt or not. In this example 4, do you have any doubt? Then let me know. If you have any doubt on question number example 4, let me know. I just want to give you some homework because this chapter practice is very important. Is there any doubt in this still? Let me know if you have any doubt. Otherwise, we will do some other question. Okay, still no response.